We are leveling up right now. We are going to multi-step equations. Oh man, can it get any more exciting? I mean, this is a perfect time for this lesson because we have Thanksgiving and we can just sit around the table, eat our turkey, and be like, I'm so thankful for multi-step equations. All right? Yeah, right. Okay, we are simplifying algebraic expressions first, and then we're going to be solving equations. And those equations are mostly going to have variables on both sides. The other big objective is to understand what it means to have, there's three new types of solutions. There's going to be no solution, one solution, and infinitely many solutions. So I forgot that in my objectives, but you have to know the difference between no solution, one solution, and infinitely many solutions. Okay? We sometimes call this the null set, and we call this identity. All right? Anyway, these ones, that's my little daughter yelling to my wife. Anyway, one solution is the ones that we've just typically had, where you have a variable and it equals a number, so you know that if you substitute that number in for the variable, then it'll make the equation true. The other ones, they're a little bit weird, so we'll talk about them in a sec. Okay, distributive property, as a quick reminder, we have multiplication over a sum. Remember, a sum is addition, so we would call this a sum because it's adding two things. All right? Or we could have distributive property, right? That's multiplication because it's next to the parenthesis over a difference, so maybe x minus 7. All right, so we can have a multiplication across a sum or multiplication across a difference, and we would then distribute that multiplication in, get 2x plus 6, or if we distribute that, we get negative 2x. And just as a reminder, if we're distributing a negative into a subtraction, we get addition. All right. Again, you could see that minus sign here as plus a negative, and then it works out that a negative times a negative equals a positive 14, so you're adding a positive. There we have it. Okay, don't forget gems. We got grouping symbols first, then exponents, then multiplication and division left to right, and we have subtraction and addition also left to right. Sorry, my scribbles. I'm just trying to make this short for you so that it doesn't take a long time. Now, we have simplifying versus solving. Okay, that's like using gems to do gems. Can I spell? There we have it. Using gems to do operations, right? And then solving is like using the reverse to undo operations, right? We're doing the inverse operations there, so we're kind of like undoing all the operations to isolate the variable. Okay, so we're gonna be simplifying before we can solve. That's the key. Simplifying first, and then solving second. Here we go. Our first example, we want to simplify first. So let's write this down. We have 15 times the quantity, 20 plus d, and that's going to equal 420. Sorry about the shimmy shaking there. I was writing on top of my textbook, and it was making all sorts of weird noises. All right, so first we want to simplify. All right, and we're just going to use either distributive property or combining like terms in this case. All right, so we can distribute here first, and we get 15 times 20, which gives us 300, plus, common mistake, you do all that math and get the 300, and then you forget to do that second multiplication. Okay, we have the 420, and now we're ready. once we simplify, we're ready to solve. And as soon as I'm ready to solve, that's when I draw my line down. It kind of helps me distinguish between the steps of simplifying and solving. All right, so which one do I get rid of first, the 300 or the 15? Hopefully you said the 300 and you're like, because it's the term without the variable. We get rid of that first. We can always get rid of terms with subtraction or addition. Now we have 15d. We're going to subtract and get 120. And we have a coefficient of d that's multiplied by the d. So we're going, because we're solving, we're using inverse operations. We're going to divide by 15, divide by 15. D equals, let's see, I think it goes in 8 times. 12 times, sorry. Not 12 times, nope, I'm wrong. 8 times. Yeah, 30 goes in 4 times, so 15 has to go in 8 times. There we go. All right, so D equals 8. That means if we replace that original D with 8, we would get the answer of 420. All right, let's move on. We're going to try these problems. We want to simplify before we solve. That's simplify, then solve. All right, so we're going to distribute first. That gets us negative 27 plus negative 3x equals 33. Now I draw my line down because there's nothing else I can simplify. So now I'm ready to solve. I'm getting rid of the non-variable term first. So I'm going to add 27 and add 27 to keep it balanced. My property of equality. Bring down the negative 3x. And when I add these, I get a whopping 60. And now I'm ready to divide, because that's the inverse operation of multiplying. And I get a positive divided by a negative is a negative. 60 divided by 3 is 20. All right. I bet you could do this. Why don't you pause and then unpause to check if you're right. I'm distributing first. I want to simplify first. 3a minus 35 equals 25. Next, there's nothing else to simplify, so I'm solving. Add the 35, add the 35. 5a equals, that's going to be 60. Now I look at my variable. I realize it's being multiplied by the 5, so I'll undo that and get x equals 60 divided by 5 is 12. All right, so now we're going to take it up a little notch here. We're going to take it up a notch, and because we're going to have variables on both sides, so it's going to get a little messy here. This is what we're used to, one solution. All right. Null set, what's going to happen is your variable term is going to completely cancel out. Okay. And what you'll get is a number equals another number. And since 4 does not equal 0, that's just telling you this problem's messed up. There's nothing that's going to make this true. All right, nothing will satisfy this equation. Nothing will make it true. Okay, and then so very similarly, the identity over on the right here. All right, here the variable terms will cancel out, but instead of being left with two numbers that don't equal each other, you're going to get two numbers that do equal each other. And what that is saying is that no matter what you plug in for the variable, that equation will be true. All right, so these two, the variable term will cancel out completely. You'll be left with an equation that doesn't include a variable anymore. The null set, you'll have something that doesn't make sense. It's not true. So a number equals a different number. And then identity, you'll have a number that equals itself. All right, let's give some examples. And not only are we taking it up a level with our null set and our identity, but we are also having some more complicated problems here. Remember, we're always going to simplify first. Look to simplify. Can we distribute or combine like terms? And in this case, we can distribute. So we will distribute and distribute. So that's going to be 6x minus 18 plus 10 equals 6x minus, let's see, 2 times negative 4 is going to be minus 8. Now, I'm not going to draw my line down because I see one more thing to simplify. I'm noticing here, these two terms are like terms. This is an odd man out. So I just bring him down, and I'm going to combine those, the negative 18 plus the 10, and that gives me negative 8, 6x minus 8. Now, you'll be able to tell sometimes when you get to a point like this, oh, it's the same on both sides, exactly the same on both sides, so I know immediately it's identity. I'm going to take it a little further because I mentioned that the variable terms cancel each other out, leaving no variable in the equation. Okay, so if I say, oh, variables on both sides, it looks like I'm going to have to get rid of one of those. So if I subtract the 6x here to cancel it out, I have to subtract 6x here, and what happens? They both cancel out. So I'm left with negative 8 equals negative 8. And since we get a true statement with no variable, all right, we call that the identity. And our solution is infinitely many solutions. That means pretty much any number you plug into this problem, it's going to make it true. So if I look at this, right? If I look at this and I put a 2 in for the x and a 2 in for that x, it's going to pump out the same exact number if I simplify on the left side of the equal sign as it does on the right side of the equal sign. And if I plug in a 3, you're going to get matching numbers on the left and the right eventually once you simplify. All right? Any numbers you plug in for x is going to make this true. There's not just one solution like normally there is. Let's try another one. Here we go. First step is to simplify. Distribute. We have 32 minus 16x equals 12 minus 20x plus, bring down this guy because he's not getting distributed to. He's not in the parentheses. Is there anything else to simplify? I see over here that I have that 12, I have the minus 20x and the plus 4x. So I see that I have like terms I can continue to simplify before I start to solve. So everything on the left side is simplified, but I can combine these two like terms. So negative 40x plus negative 20x plus 4x is going to be negative 16x. And you might see something. You might see that looks like those variable terms are very similar. So that's kind of the tip, the clue that we're going to have one of those weird solutions. All right, either null set or identity. Now, when I try to cancel out one of the variable terms because I have variables on both sides, I go ahead and cancel it out. Plus 16x cancels. Plus 16x, that cancels as well. What's going on here? I got something that's not even true. Okay, so we get a false statement, and variables cancel out. All right, so when we have that, we call this the null set because x doesn't equal anything. All right, or we say there's no solution. Okay, so when the variable terms eventually cancel out and you're left with two numbers that don't equal each other, that's what we say is a null set or no solution. All right, you can do these yourself. Why don't you go ahead and try them, pause it, and then I'll come back with you to show you the answers. So here we go. I did it all and didn't make you sit through listening to me talk about it, but you can copy down this work if you didn't do it, and as well as try to find your mistake if you made one. All right, so those are the two situations that you'll run into, and that is all for this lesson. Good stuff. Let me know how you're feeling about the lesson, and I'm sure you're very thankful for learning this amazing math.